All right, in this section, we're going to look at the product and quotient rules for finding a derivative. All right, in this section, we're going to look at the product and quotient rules for finding a derivative. The product rule says if I have two functions that are both differentiable and I'm multiplying them, when I take the derivative, I multiply the first function, f of x, times the derivative of the second function, g of x, and then I add to that the second function, g of x, times the derivative of the first function. So first times derivative of the second, plus second times derivative of the first. That's how I kind of read that. And sometimes, because of all the notation, it's sometimes written as functions uv instead of f of x and g of x. So u is the first, v prime is derivative of the second, v is the second, u prime is the derivative of the first. Okay, so here we have f of x equals 3x squared times 4 minus 5x. Now, we could distribute the 3x squared and go back and just use our power rule, but we want to see how that product rule is working. So the 3x squared is f of x, 4 minus 5x is my g of x. So f of x is equal to 3x squared, and then f prime of x is going to equal 6x. Okay, g of x is equal to 4 minus 5x. G prime of x is equal to negative 5. So now when I want to find my derivative of the whole thing, which is f prime of x, and that's why sometimes we use u and v. So that's u prime, that's v prime, because we don't want to get confused with f and f. Maybe I should call that h and h prime. To find f prime of x, I'm going to take the first, which is 3x squared, times the derivative of the second, which is negative 5, and then I add to that the second times the derivative of the first. And then I got to clean that up. So 3x squared times negative 5 is negative 15x squared. 6x times 4 is positive 24x. That's a minus there. And 6x times 5x is negative 30x squared. So I can clean this up and say it's negative 45x squared plus 24x. So there's my derivative. Now remember, we said we could have multiplied this out at the beginning, and if I had, I would have had 12x squared minus 15x to the third. And if I was using that function and I wanted to find my derivative, I would have 2 times 12, which is 24x, and then 3 times negative 15 would be negative 45x to the second. So I got the same thing either way, and the more you do these, the more you see that sometimes one method is better than the other, and it will just take some practice. All right, so find the derivative. Oop, lost my derivative sign there. Finding f prime of x. F of x is x squared plus 1 times 1 over x. Okay, so again, we can use our notation. So I'm going to say the first function is x squared plus 1. The second guy is 1 plus x, so I'll call it u is x squared plus 1. So u prime is equal to 2x. V is equal to 1 over x, and remember we rewrite that as x to the negative first. So v prime is equal to negative 1x to the negative second, which is negative 1 over x squared. So now to get my derivative, I can say f prime of x is equal to the first, x squared plus 1, times the derivative of the second, negative 1 over x squared, plus the second, 1 over x, times the derivative of the first, 2x. So if I distribute, I end up with negative 1 minus 1 over x squared plus 2. So this is 1 minus 1 over x squared is my derivative. Well, if we have a product rule, it means we have to have a quotient rule. So quotient rule is when I'm dividing two functions, f of x divided by g of x. The rule for the derivative is the lower function, gx, times the derivative of the upper function, f prime of x, minus the upper function, f of x, times the derivative of the lower function, g of x, all over the lower function squared. So for me, when I do this, I think of this as low d high minus high d low all over low squared. I feel like I'm yodeling when I do this. Low d high d low, low squared. All right, so here we want to find the derivative of f of x equals 3x plus 1 over 5x plus 2. Now, I can't simplify those, so the only other way I could do this besides using the quotient rule would be using my formal limit definition for the derivative. So I'm going to use my quotient rule. So I'm going to say u is the upper function, which is 3x plus 1, and the derivative of that is 3. I'm going to say v is my lower function, 5x plus 2. The derivative of that is 5. So now, when I find my derivative, f prime of x, I have to remember to yodel. So it's low times the derivative of high minus high, 3x plus 1, d low, which is 5, all over low, 5x plus 2, squared. Now the calculus part is done. Now it kicks into algebra. We have to clean that up. So this becomes 15x plus 6 minus 15x minus 5. Remember, I had to distribute that negative. All over 25x squared plus 20x plus 4. I can combine like terms, so my numerator becomes 15x. 6 minus 15 is negative 9. Negative 9 minus 5 is negative 14 over 25x squared plus 20x plus 4. And then I can't simplify that any further. All right, let's try yodeling again. So here I have f of x equals the square root of x over x squared plus 1. And again, I need to find f prime of x. So I'm going to start with saying my upper function u is the square root of x. So remember, that's just equal to x to the 1/2. So that means u prime is equal to 1/2 x to the negative 1/2. So that's 1 over 2 square root of x. I'm going to stick with the exponent method for now because I don't like to put fractions into fractions. The lower function is x squared plus 1. The derivative of that is equal to 2x. So now f prime of x equals low, x squared plus 1, d high, 1 over 2 square root of x, minus high, x to the 1/2, d low, which is 2x, all over low, x squared plus 1 squared. Okay, calculus part done. Now the algebra kicks in. This one is a little bit messy to simplify, and as you're working through on some of the problems, I'll ask you to not simplify, and other problems I will expect you to simplify and do the algebra. On this one I'll keep going a little bit, so I'm going to have x squared over 2 radical x plus 1 over 2 radical x minus 2x to the 3/2 all over x squared plus 1 squared. To clean this up, we'd have a lot of work to do, so we're going to leave it like that just for now. All right, we're given f of x equals x times 3 minus x over 2x squared, and we want to find the derivative. There are multiple ways we can do this. We're just going to look at 2. So the first thing I'm going to do is say, well, I can simplify f of x, because x divided by 2x squared, I'm just going to have 3 minus x over 2x, and now I'm going to use my quotient rule. So f prime of x equals low d high minus high d low all over low squared. So now I have negative 2x minus 6 plus 2x over 4x squared. Negative 2x and positive 2x add to 0, so this is negative 6 over 4x squared, and that simplifies to negative 3 over 2x squared. Okay. On the other way, I can do it another way. I could use a product rule with a quotient rule. So I'm still going to simplify that because that makes my life, I think, a little bit easier. But I'm going to make this x over 2x squared times 3 minus x. And then I can simplify that and say f of x is equal to 1 over 2x times 3 minus x. So now to find my derivative, f prime of x, it's the first times the derivative of the second plus the second times the derivative of the first. So the derivative of 1 over 2x, remember 1 over 2x is really 1/2 x to the negative 1. So that's going to be times negative 1/2 x to the negative second. So here I have negative 1 over 2x minus 3 over 2x squared plus x over 2x squared. So the negative 1 over 2x and the x over 2x squared are going to add to 0, and I get the same thing, negative 3 over 2x squared. Now you would always rewrite that. I kind of ran out of room, but notice I did it two different ways and I got the same thing. I also could have just not distributed anything and done a combination of the product rule and the quotient rule. Let's try another one. Again, we can use two different methods. So the first one, I'm just going to use my quotient rule because I see two things being divided. So to get f prime of x, I yodel, so I do low, d high, derivative of x squared plus 5x plus 6 is 2x plus 5, minus high, x squared plus 5x plus 6, times the derivative of low, which is 1, all over x plus 3 squared. Okay, I got to clean that up. So I'm going to double distribute in my numerator. So I have 2x squared plus 5x plus 6x plus 15 minus x squared minus 5x minus 6. And that's all over my x plus 3 squared. Combining like terms, 2x squared minus x squared is x squared. 5x and negative 5x is gone. Plus 6x, positive 15, negative 6 is positive 9 over x plus 3 squared. But x squared plus 6x plus 9 factors to x plus 3 squared. So now I have x plus 3 squared over x plus 3 squared. This is just equal to 1. So I found my derivative using the quotient rule. Now, the other option I had was I could have simplified the function first. So I could have said, okay, wait a minute. F of x is equal to x plus 2 times x plus 3 over x plus 3. The x plus 3 simplify, so f of x is equal to x plus 2. F prime of x is equal to 1. So again, there are always multiple ways to find your derivative. Sometimes it's a good idea to use two different methods to check yourself. Sometimes one method is a lot shorter or more simple than the other one. Okay, so here we have f of x equals x squared times x plus 4 minus 2x over x squared plus 1. So again, we can do this multiple ways. I'm going to first try to simplify as much as I can because I like to take derivative of as simple of a function as I can. So f of x here would equal x cubed plus 4x squared minus 2x over x squared plus 1. That I can't simplify. So now to get my derivative, I do the derivative of each term. Derivative of x to the third is 3x squared. Derivative of 4x squared is 8x to the first. 2 times 4 is 8. 2 minus 1 is 1. Minus, and here I have to be very careful because now I'm going to use the quotient rule. So it's low, x squared plus 1, d high, which is 2, minus high, 2x, d low, which is 2x, all over low, x squared plus 1, squared. Now I need those brackets there. Without the brackets, I wouldn't be distributing that negative, and I could end up with an incorrect answer. So now we're just going to simplify the calculus parts over. We're moving on to algebra now. So 3x squared plus 8x minus, I have 2x squared plus 2 minus 4x squared, all over x squared plus 1 squared. So now I have 3x squared plus 8x minus negative 2x squared plus 2 over x squared plus 1 squared. So now I have 3x squared plus 8x. When I distribute my negative, I'm going to have plus 2x squared minus 2 over x squared plus 1 squared. I could get common denominators and put it all together. We're going to stop for there. Now we can also use our product and quotient rules if I'm given a table of values. I don't necessarily have to have the whole function. So here I'm told that when x is 2, f of x is negative 3, f prime of x is 5, g of 2 is 2, g prime of 2 is negative 4. So if I want to find the derivative of f times g at 2, I'm going to have to do, again, product rule. First times derivative of the second plus second times derivative of the first. And then I can use my table to fill in those values. F of 2 is negative 3, g prime of 2 is negative 4, g of 2 is 2, f prime of 2 is 5. So I have 12 plus 10, so this equals 22. So just another way that we can also evaluate derivatives using a table. Same thing with quotient rule. So I have f over g prime of 2, so this is going to be low, g of 2, times high, f prime of 2, minus high, f of 2, d low, g prime of 2, all over low, g of 2, squared. And now I'm just plugging in those values. So again, g of 2 is 2, f prime of 2 is 5, f of 2 is negative 3, g prime of 2 is negative 4, all over g of 2, which is 2, squared. So here I have 10 minus negative 3 times negative 4 is positive 12 over 4. So this is negative 2 over 4. So this derivative is negative 1/2.